All right, so let's finish up 6-2 and look at example 3. So we are to find the values of x and y in, they're using this symbol for parallelogram. I kind of prefer you not to. I mean, if you're going to use it, then that's the only thing you can use that symbol for. And my point is that some of your handwriting isn't that terrific. Let's just be honest. And then when we get to squares and rectangles, we cannot use a symbol for square or rectangle because we can tell the difference between those sometimes. The textbook can get away with it because they can draw nice, precise, accurate pictures. But that is what they're telling me. So we know that we have a parallelogram at the right. What's this notation asking me? What are PR? What's that asking me? The distance from P to R and the distance from S to Q. So that's the distance of the diagonals. Or I guess they're asking what are. If they're going to ask that question, then my response would be what is, or what are line segments PR and line segments SQ? Aren't they diagonals? And then they go on to here to say that PT, so from P to T, and T to R, those are congruent. And then ST, bless you, and TQ, those are congruent. Why? Because diagonals bisect each other in a parallelogram. So there's your reasoning there. This isn't why. And this does not happen in just a plain parallelogram. It will if the parallelogram becomes more specific. Cross-out equation is not true. I want you to look at those and figure out which one is not true in regards to parallelogram. Are there two that seem to be not true? Which two do you think are not true? The first one. Well, the first one, like where do you get those numbers? I see the 2x here, right? And it's equal to this gobbledygook. Shouldn't it be this? Let's see what that's actually equal to. Distribute the 3. And what do you get? 3x plus 3. And then minus your 7. What's 3 minus 7? Negative 4. Does that match that? No. Right? So, and I'm not crazy, what does that say? Is that a 1? Oh, it's a 7. And so that one doesn't appear to be correct. Did we make a mistake? Nope. And then this one, where'd they get this one from? So this piece of the diagonal y is equal to x plus 1. Do you agree with that one? That's true. Those are the pieces of the diagonal that are bisected. And this one, they've got 3y minus 7 is equal to x plus 1. Is that true? That's not true either. These pieces are not all equal to each other. They're only equal to the same piece that's on the same diagonal. And then 3y minus 7 is equal to 2x. Is that true? Yeah. So these are the only true ones. So we want to find the value of x. So let's take this one here. Why? What's the problem? Okay. So I have 2 equations with 2 unknowns. How do you solve 2 equations with 2 unknowns? You could use substitution, you could use elimination, and you could eliminate if you got your x's and y's on the same side and you line them up. They do have this nicely set up so that we could take the value for y, which is x plus 1, and substitute it in for that value for y there. Correct? And so then I would have all x's. So we're going to find the value of x by taking 3 times. And instead of this y, we're going to replace it with a y that it's equal to, which is x plus 1. and then minus 7 equals 2x. So that's using substitution.
So first equation 1 is true.
Say that again.
The first equation 1 is true.
Aha. First equation was true. Where'd they get that from? Yeah. And so, good point. So, the first equation, and we wouldn't have known that unless we'd used substitution. Actually, I wouldn't have even seen that if we'd used elimination, would we? And if we had gone further and actually simplified, well, we still wouldn't have seen it. Unless we specifically use substitution here. So the first equation is actually true, right? So now go ahead and distribute. 3x plus 3 minus 7 equals 2x. Combine your like terms. So you have 3x minus 4 equals 2x. You could do one of two things. I like to keep my variables positive. So if I subtract 2x, that'll keep my variables positive. But then that leaves me what on this side? 0. Can't I do 2 steps in one now that we're in geometry? Are you okay with me adding 4 up both sides at the same time? Like I told you, my x is there, my 4 is there. So we end up with x equaling, that gives you x, 4. So that was one of the things that they're looking for. You find one. You can plug in x into either of the 2 equations up here that we said were correct. And then find y. When you get a value for y, share it with those around you. Share it. What'd you get for y? Everybody, what'd you get?
5.
There you go. So that's the easier equation to plug it into. You could have plugged it into the other one. But that one's the least amount of work. So then what I would like you to do is answer the following questions down here related to what you just found out. So they want you to find the distance from P to T. The distance from P to T is 3y minus 7. And so that's what they're walking you through here. So if you would answer 23 through 27, I'll give you about 2 minutes. Should be enough time. Make sure you're choosing the right things to plug in. Okay, show your answers. Ian, share. That means your head's off the desk and you're talking. All right. So here are your solutions. Tell me if I made a mistake. Don't make a mistake. Always possible. My only problem with doing it this way is if I did make a mistake, would I have found it? No. And mostly doing it this way here, taking each of the smaller segments of each diagonal and doubling them, does get you the measure of the whole diagonal. But if I made a mistake here, I'm going to make a mistake here and I'm going to catch it. I always, especially if I'm on a test, would prefer to find if the measure of PT, I plugged in 5 for Y, and that gave me 8, then I would want to find TR, which involves X. So I would want to take 4 times 2, which is 8, and compare the two. Since they both equal 8, I'm pretty comfortable that I must have come up with the correct answer, both for X and for the values of those segments. And then when you do add them together, you do get 16. So do keep that in mind. You do run the risk of compounding your error. And then I was very wordy here, but if you can say the same thing without being so wordy, more power to you. So essentially, since each of the segments in the diagonal are equal to each other on the same diagonal, you just have to double them. That's all that was trying to tell you. You don't have a theorem that says that. All right, so then let's look at theorem 6-7. So it's one more theorem associated with not necessarily parallelograms, but parallel lines that are cut by several transversals. So if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So you can see right here in the picture that there's a tick mark here and a tick mark here. It's a little bit hard to see. But that's what they're referring to when they say cut off congruent segments. Then the implication is that these segments over here, they're not necessarily equal to from A to C, as you visually can see that these are not equal. But it does create congruent segments over here. And so it cuts off congruent segments on every transversal that goes through those parallel lines. So we can use that information to help find various lengths. Then it goes on to say if line AB is parallel to CB, which is parallel to EF, AC is equal to CE, and so therefore BD is equal to, what do you want to put here? BD is equal to what? DF, line segment DF. And then we already marked our picture. So let's see how that's used. So you'll see it used in various ways when you do your homework, word problem wise, as well as non-word problems. But here's a particular picture. They tell you at the right, all of these lines are parallel. And you can see the parallel markings for yourself. So if they didn't tell you that, the markings in the picture are telling you that. If EF is equal to FG, so EF is equal to FG, mark up the picture, which is equal to GH. And they all equal 6. 6, 6, 6. 6. Does that make you feel better? I'm just going to create that over here, just to make you feel better. And then AD is 15. So the whole distance from here to here is 15. What is CD? So we're going to let CD be X. If these segments are congruent to each other, what do you know about these segments? They're congruent to each other. So I'm going to put double tick marks in there. So if that's X, then the distance from B to C is X, and the distance from A to B is X. And so we're not going to do that. It's a little confusing. Can't we just set up an equation saying that 1 plus 2 plus 3x's is a total of 15? And so x is a distance of what? 5, which is what CD is equal to. And then finally, your lesson check. So if you would take a minute or two and answer those questions. So share your thoughts with those around you regarding what they're giving you. Lines can be cut by transversals that are not parallel. The pictures look identical, but the only thing that they haven't told you is what? Right, but the theorem says that if 3 or more parallel lines are cut by transversals, and those transversals cut congruent pieces, then the other pieces on the other transversals are also congruent.
Why is this
Consider what? Because the distance between the parallel lines on that transversal, that's the parts that are cut, or the parts on the transversals that are cut by the parallel lines. So the parallel lines are the cutters, the knives, and the transversals being partitioned. Okay, so listen up. I will grant you that you could argue that VS is 5 with the information given. You really could. Logic stands to reason. The theorem that we're working with says that if 3 or more parallel lines, keyword parallel lines, are cut by a transversal, and if those lines cut that transversal into congruent pieces, then all transversals are cut into congruent pieces that are going through those lines. That's essentially what that theorem is saying. I ask you, what is the converse of that theorem? What would be the converse? Well, look at your theorem on the other side of the paper. If 2 or more. So here, look at the theorem. So it says if and you'd have to put in here, if two or more transversals are cut into congruent segments, then those lines are parallel, or all lines of those transversals are parallel. Would you say that that's true? I mean, look at the picture here. This one showing non-parallel lines, and we're not told we have parallel lines. Logically, from if P to R is the same distance as from R to T, could you have non-parallel lines? Could you have non-parallel lines? Really? Doesn't parallel lines mean that the lines are the same distance apart all the way through? And if this is not the same distance as this one, I mean, it does depend on where that transversal is, so this is not necessarily going to be the same distance as from here because it depends on how you tilt that transversal. But these transversals are not perpendicular, are they? So remember, it's perpendicular distances that really tell you the distance between two lines, but it stands to reason if these are the same, the lines have to be the same distance from here to here to here to here. Those also have to be the same. So you're going to find later that you're going to get a converse to this then that says that if this is true, then the lines are parallel. But you haven't been told that yet, so you're not allowed to make that determination. But some of you might be thinking, well, logically that has to be true. The only thing you've been given is that you have three lines cut by a transversal. You are not told that they're parallel. And you are told that you have congruent segments on one of the transversals. So according to the theorem on the reverse page, what needs to be true that all three of those lines need to be parallel before you can make the assumption that QS and SV are equal segments. So if the above lines are not parallel, you cannot conclude that those segments are equal. Yet. Keyword yet. Any questions about that? All right, so let's look at your workbook page. So look at page 152, which is the back side of what we were dealing with yesterday. Now, as you look at this picture for questions 13 through 16, you are not told, you are only told that you have parallel lines, right for the picture. And then over here, you are told that TU is congruent to UV. TU is congruent to UV. What's your conclusion? You have three parallel lines. You have two segments on one of the transversals that are equal distance from each other. What's your conclusion? Mariah, I hope you're listening. What's your conclusion? What were we just talking about? If three or more lines are parallel, and one of the transversals is cut into equal segments, what's your conclusion about the other transversals? They're cut into equal segments as well. So wouldn't QR be equal to RS? So if RS is 3.8, wouldn't that be QR as well? So wouldn't this equal 3.8? No math needs to be shown, other than obviously you're drawing the picture when you go to do your homework. And then on top of that, wouldn't NM be congruent to ML? So wouldn't ML, which they didn't ask you for that. I'm sorry, they did. They asked you for MN. Wouldn't NM be 4.5? So I want you to find the distance from L to N and the distance from Q to S, please. would you get for LN? What's the distance from L to N? What's 4.5 plus 4.5? 9. What's the distance from Q to S, number 16? 7.6. So you could have added 3.8 twice, or you could do what I put on there, just double it. Then I want to look at questions 17 through 24. So we're going to actually do all of these. So you're going to spend a few minutes working on all of these. You can work in pairs. You can work singly, and then once you get the answers, you can chit-chat about them. But you're all working on these. That's an angle. But 70 is not opposite.
Oh, this is one, so 2 is
Right. And then those are vertical. If you get stuck, I want you to seek help, phone a friend, not literally just figure it Make sure that you use your knowledge of alternate interior angles on parallel lines. Eric, are you all done? Completely 100%. Did you do it before I asked you to do it? Seriously, no, walk over your done. Did you use a calculator? Why don't you share and help people who are confused? Use your powerful brain and put it to good use. Are we doing okay, ladies? Yeah? Miss Ashley, doing okay? Yeah. Bailey, you okay? No? What's wrong? Anybody else?
It says corresponding angles. No, corresponding angles.
Okay, so let's go ahead and look at what we have. All right, you ready? Get in the habit. Some of you are afraid to draw in that picture. Right in the picture. Because if you put it out to the side, it's hard to see and it doesn't free up your brain to think. And it sounds weird, but it's true. So get in the habit of writing. The ones I didn't show work on, I was usually just subtracting the angle measure from 180 or it was equal to another angle. So like on number 17, opposite angles are equal, so I know that 2 had to be 75 as well. These are consecutive angles, so they have to be supplementary. So I just took 75 and subtracted it from 180 and got the 105. So if you don't see work on mine, that's typically what I was doing. On number 20, these are opposite angles, so you start with the fact that this one's 60. Just because you may not need to find this angle doesn't mean that you don't need it to find an angle that you are trying to find. These are parallel lines, and so these are alternate interior angles on those parallel lines, so they are congruent. Once I got that 60 from here, now I have 2 angles in one triangle. The interior angles of that triangle add up to 180, so I knew that angle 1 had to be 60. So I subtracted 120 from 180. Plus, if that's 60, 60, you should recognize that that's 60 because that's your angular equilateral triangle. So then that means that 2 is also 60. And then you came to 19 and 21, which were a little bit more difficult problems. A lot of you recognized, for instance, that 1 and 3 had to be congruent because they're alternate interior angles on parallel lines. But in order to find them, these are not equal. I don't know that this is an isosceles triangle, so I cannot make the conclusion that those are equal. What I can do is conclude that 78 is also 78 here because they're vertical angles. That then gives me 2 angles out of the 3 in that triangle, and so I just added them together here and subtracted them from 180, and I was able to get that 3 was 54. And so if 3 was 54, then angle 1 was also 54. And don't forget your linear pair combinations as well. So 78 and angle 2 form a linear pair, so they're supplementary, so I just subtracted 78 from 180 to get that one as well. And you could have used that one, angle 2, to find that angle as well, either way. And then down here, it's slightly different from 19, but yet they are somewhat similar. I still use the 75 vertical angle here. Then combined with the 50, I subtracted that value from 180 to get the measure of angle 3, which was 55. It's alternate interior to angle 1, which also makes that 55. And then again, the 75 and the angle 2 form a linear pair, so they're supplementary. And then most of the other ones, you're either using opposite angles are congruent or alternate interior angles are congruent. And then this one was just like 19 and 20 for the most part.